In this video, I want to talk about measuring plate movement. Now, scientific instruments such as sonar, as I mentioned in previous videos, so sonar and magnetometers measure magnetic fields, right? Sonar sends out echoes, okay? These actually gave scientists information about the Earth, okay? And ultimately, on theories of continental drift, to help give them evidence, continental drift and plate tectonics. Okay, sonar magnetometers. Now, newer technology actually shows plates don't actually move according to these theories. Okay, so these theories suggest that plates move a certain way. Newer technology actually shows otherwise. Okay, and the most widely used technology is GPS. GPS stands for the Global Positioning System. Okay, you've basically got on the ground. You've got a GPS ground station. Okay, and that's a receiver basically. It's a receiver and a computer that are placed on top of a stand. Okay, so you've got a receiver and a computer placed on a stand, and that's stuck onto the earth, right? It's put into the ground. Now the legs of the stand are actually fixed into the rock, okay, beneath the ground. And the GPS works by, you've got the earth and you've got about 24 satellites in orbit around the earth, okay, and they send radio signals. Remember, communication, we use radio signals most of the time. Okay, they send radio signals to the GPS ground station, right? Now, the ground station needs to detect at least 3 satellites to calculate how far it's moving, okay, and in which direction the rock's moving. Okay, it needs 3, at least 3. And it also needs at least 4, if 4 are detected, so if more than 3, if 4 is detected, then you can also work out how far it's moving vertically, so up and down, left and right. That's how it gets the information. Now, the ground station computer works this out by then sending the data. So it sends the data by a communication satellite. Communications are linked to the scientists. Okay, the scientists' home base. And by comparing all the data from the different grid stations on the Earth, so by comparing data on different stations around the Earth, scientists can then determine how far the grid stations have moved compared with the others. Okay, and using data from many GPS ground stations, it gives an accurate picture of how the grid's moving. Oh, sorry, how the ground is moving, not the grid, sorry. Okay, so using data from many GPS ground stations gives an accurate picture of how ground is moving. Okay, and GPS actually relies on Einstein's theory of relativity. Just thought I'd mention that. And without his theory, without Einstein's theory, it would actually fail. We wouldn't be able to tell where things were. Things would be off by hundreds of kilometers, apparently. It's a very accurate system using satellites, and as you know, satellite communication is accurate. It makes use of advanced technology, and that's why we can tell how plates are moving left, right, up and down in the Earth. So think of the plate as a car, right? The car, and the plate's got a GPS system. Well, it's actually the ground station that has it, but it's connected to the rock, and the satellite tells the computer how far the rock is moving, the plate's moving.